conservation begins with affection. But what happened to me was that affection turned to intense admiration. Here are systems that work together to be completely, not just sustainable, they work to enhance the place. All these organisms living together. Each of them are full of amazing adaptations that together work to make of every single habitat an Eden for them, a lush and livable place. And I thought, that's exactly what we're looking to do here on this planet. And is anybody trying to emulate these organisms? Has anyone had that sense of admiration, that aha of from affection to admiration, to deep respect, to realize that these are the consummate engineers, chemists, physicists, of our planet, the aviators of our planet, the sailors of our planet. They've done everything that we want to do.
This is a story about an engineer at J.R. West. They're the people who make the bullet train. It was called the bullet train because it was rounded in front, but every time it went into a tunnel, it would build up a pressure wave, and then it would create like a sonic boom when it exited. So the engineer's boss said, find a way to quiet this train. He happened to be a birder. He went to the equivalent of an Audubon Society meeting, and he studied, there was a film about kingfishers. And he thought to himself, they go from one density of medium, the air, into another density of medium, water, without a splash. Look at this picture, without a splash, so that they can see the fish. And he thought, what if we do this? Quieted the train, made it go 10% faster on 15% less electricity. We're not the first ones to build. We're not the first ones to process cellulose. We're not the first ones to make paper. We're not the first ones to try to optimize packing space or to waterproof or to try to heat and cool a structure. We're not the first ones to build houses for our young.
The concept is not new. Leonardo da Vinci was one of your earliest biomimics. He had been looking to nature for a lot of his innovations and designs. And when Janine wrote the book, that's really what she was writing about, was how scientists and innovators around the world were looking to nature for solutions.
I was looking for someone who was studying a leaf in order to create a better solar cell, or somebody who was studying the spider's incredible fiber in order to figure out a way to make fibers without high heats or toxins or high pressures. People who were, studying prairies in order to learn about how to do a whole new kind of agriculture. Even people studying forests and coral reefs in order to figure out how to create a circular economy. There was this thread that bound them all together. This shining thread, I kept seeing that shining thread, This is all looking to nature for inspiration. What's the name for nature-inspired innovation? Bios is Greek for life, and mimesis is mimicry, and I thought it was biomimicry would be more melodious, and I just scrawled that on the tab. Isn't this what designers and architects and engineers start with? Don't they say to themselves, what in the natural world has already done what it is I'm trying to do? How do you create something that will allow ideas to flow naturally so that at the moment of creation, when an inventor is trying to figure something out, they're not bouncing around their own heads, for ideas, but rather instead of flipping through magazines like they do now to look for ideas, they walk outside.
I did a course for the built environment. I ran the course, and my colleague put in a section on biomimicry. And I fell in love with the potential because, having played in the problem space for quite a long time, I realized how powerful the solution was. It's probably been the best thing I've ever done in my life, probably the most important thing.
You bring people out into this environment And they have a certain view of nature as something out there, not a source that they would go to for solutions. And you watch the magic of what happens. You see this light go on in their eyes and in their faces, and the whole way they think changes.
I didn't know that I was coming to learn such things, and I didn't even know what biomimicry was. But with these few days that I've been here, I've learned a lot about the nature itself and how to connect as a human being with the nature.
What's exciting about biomimicry is that it approaches nature with a sense that people need to be humble and need to seek a way of learning from nature, and in that learning appreciate her services. What is very clear from being here is that it's so easy for anybody to really drop into that mindset.
What fascinates me about biomimicry is this transformation from us as conqueror to us as student. Difference in our stance towards the rest of the natural world. The 99.9% of the time we've been on Earth as a species, we were hunters and gatherers. We were living in really close interliving with our natural environment. Our survival depended on noticing the small, fine details. Conventional wisdom tells you that the internal combustion engine will be with us forever. The move to hybrid was, well, no. Perhaps we don't have to have fire in our engines. Perhaps we can do it with a silent electric motor. When you look at something like an electric eel, it generates 600 volts of electricity instantly using bodily chemicals. There are people that are actually looking at this as a model for new ways of storing and generating energy. Tires that could grip as well on wet surfaces as a tree frog's pads grip. Windshields that are self-cleaning, like the lotus leaf. Those are the kinds of things that would really interest car companies. Africa is large and strong and rich and full of incredible biodiversity. There's like this deep, historic, genetic connection to this place. And I hadn't thought about that really until I came here, that this is where Homo sapiens sapien evolved, came from. The well springs of good ideas are these habitats. So, these zebra, there's lots of theories about their stripes. These plains animals have to stay cool. So the theory goes that the heat rising off the black stripes creates a vacuum that pulls air across the white stripes, and that's where the sweat glands are. They actually create their own air current to evaporate away their sweat, to keep them cool when they're under blasting heat. Architects are looking at this and saying, what if we were to put patterning of color on our buildings to reduce the heat load on the building skin, so you don't need as much air conditioning?
We're trying to come up with buildings that have a lesser impact on the greater environment. It's really the idea of a building that uses less energy, less water, that uses better resource, or they use better its resources. Coming from a design background, you very quickly jump to conclusions. What's been exciting is really the idea of slowing down and thinking about the process and thinking about how there are many more factors to influence the design. And biomimicry comes right in there at that initial upfront thinking process.
What if we thought about our buildings as extensions of our physiology? This termite mound is basically a lung, an extension of the organism's physiology. They can keep it at 87 degrees Fahrenheit no matter how hot it is or how cold it is. They regulate CO2, oxygen levels. They regulate humidity levels. You talk to architects and building engineers who are making skyscrapers, and they're trying to figure out how to keep flow going in a building and how to have that building breathe. And these guys have figured it out. There is a 7-story office building in Harare that is based on the termite mound. It has no air conditioning in it, and yet it stays cool.
Once you're around these organisms and you understand how amazingly adapted and designed they are and how in tune they are with their environment, it's really difficult not to have a deep, deep respect and sense of awe.
I honestly believe that this very recent separation that we've had from living in day-to-day, daily, close, intimate contact with nature, so recent and so jarring, really, for our senses that evolved with the richness and softness and changing color palette of the forests we lived in, the savannas we lived in. I think that designers of future cities will recreate those sorts of habitat types that we were evolved to love and to thrive in. I don't think being nature's apprentice is new. It's new for us in Western industrial culture. We're remembering it. And so when people hear about the concept, there's this sort of joy of finding something you lost.
I think that in the next 20, 30 years it will become a big part of our everyday lives, and I think that knowing about it will be very important for anything you want to do, really.
It's understanding that in fact we have to do something, and that something is probably going to be successful if it is based on what nature has done for so long.
What's really important about biomimicry is that it just makes such solid sense.
It is a discipline, it is not a fad, and therefore it's something you need to learn and integrate and develop further. The field is just beginning, so I think there's a bright future ahead.
Life has been around for 3.8 billion years, and if we're going to have any hope of surviving, we have to look to the natural world.
Look at that beautiful animal. Organisms have figured out a chemistry that not only does what they need it to do, but it has to be safe for living tissue. And I think that should be a requirement of all of our chemistry. It should be safe for living tissues.
If you know that something doesn't affect an animal in a certain way, they've been using it for millions of years.
They've done the test.
They've done the test for you already. You don't need to go through that process of harmful testing or sort of ineffective testing.
I like this new use of the term animal testing. That's animal testing, but it's the kind that I'm for.
It suddenly makes you look at so many things and realizing how we just missed the most basic point of life, which was, if we have to do anything as humanity, why not create conditions conducive to life?
There's so much we can learn from the giraffe. They have this incredibly long tongue that's able to wrap around acacia. And on that tongue there's a mucus that is a very special material. It's an incredible lubricant. And that's able to protect them from the puncture. That material itself would be very, very interesting for a water-based lubricant. For every industrial process where there are machine parts moving next to each other, there's wear, and that's what causes things to break down, and then we have to replace them. And we put lubricants in there that are petroleum-based. A water-based lubricant, to learn from the giraffe's tongue, would be a real blessing to industry.
How does life make things? How does life make the most of things? That's a geranium pollen. Its shape is what gives it the function of being able to tumble through air so easily. Okay, look at that shape. Life adds information to matter. This beetle, unlike this chip bag here, this beetle uses one material, chitin, and it finds many, many ways to put many functions into it.
It's impact resistant, it's abrasion resistant, it's waterproof, it's porous, it's slightly flexible. Compare that to a snack bag of potato chips. There are 7 layers in that bag. There's a layer for ink, so you got to put the message on. There's a layer for waterproofing, you put some alumina in there, layer for structure. Every time we want a different function, we add a different material. Nature uses one material, adds a different structure to it to get the 7 functions.
The role of our department is to come up with new ideas and concepts, generally pre-proof of concept, so any radical new ideas, that's what we were interested in. We have a lot of challenges in the industry, and I'm sure there's a lot of answers here, and just a different way of looking at things. Why try and invent something from scratch when you've got this system that have been working for thousands, if not millions of years?
If you start to think about the things we call pollution, the excesses, we have excess CO2. The interesting thing about CO2 is that we think of it as the poison of our era. Life thinks of it as a building block. Everything green that you see on this planet uses CO2 to make itself. It's a structural building material. Everything that you see in the sea that is hard uses CO2 in its recipe to make its shell. When we go to make cement, concrete, we go to a mine to dig up limestone, and limestone is the ancient bodies of organisms that have taken CO2 and made it into seashells. We mine it, we take it, and we make cement out of it, we make concrete out of it. What if, instead, we learned from the mollusk how to take CO2 out of the air and turn it into limestone? What if we learned from plants how to take CO2 and turn it into long-chain polymers? They turn it into starches and sugars and cellulose. We would turn it into biodegradable plastics. It sounds like a fairy tale, but it's actually happening. There are 3 companies in the United States that I know of. They're taking CO2 from a smokestack, bubbled through seawater, and with the recipe from the mollusk becomes powdered limestone, tons of powdered limestone. In the natural world, what's abundant is golden. Right now in our economy, what's scarce is golden. The last tuna in the sea will fetch hundreds and hundreds of thousands of dollars, right? And we admire and covet what is scarce. But an organism that has to work or barter for everything that it gets loves what is abundant because it's easy to procure. There's really a difference there, big difference. Seeing nature as a teacher is very different than seeing nature as a warehouse of goods. Wilhelm Bartlett in Germany started to study the surfaces of leaves. Came across the lotus leaf, which is the symbol of purity in Asia, because as it comes up through the mud and the muck, it's pristine, it's dry, it's clean. What's going on there? How is this leaf that has to photosynthesize, comes up through the mud, staying clean? Well, he took a microscope and he looked at it closely. I mean, that's what biomimicry is. You just pay attention again in a new way. He looked closely. And what he found was, he surprised him, because our self-cleaning surfaces are completely smooth. He found this mountainous structure. It's this nano-rough structure, and the bumps are a certain distance apart, then it's waxy. What happens is that water balls up on the mountaintops, and any dirt particles on the leaf are also teetering on the mountaintops. They're loose, they're not adhered. As the water rolls off, it picks up the loose dirt particles, and it cleans the leaf. That material idea has been put into many materials now. Degasa makes a cement that's self-cleaning. When it dries, it has this rough structure, and rainwater can clean it. Many people are making Lotus Effect fabrics that you can clean with water, no detergents needed. The real difference between how life makes materials and how we make materials. We still go back to fire. Ceramics, for instance, we take a slurry of earth and water, we fire it up. What the natural world does, every hard-bodied shell in the ocean and corals, your own bones, your skin. What happens is that there's a protein template, in the abalone's case, washed with seawater, and the protein template acts as a landing site. Ions come down and land, and the shell crystallizes out of the seawater. Crystallizes automatically, self-assembles, twice as tough as our high-tech ceramics. So if you look at a material like Kevlar, the first thing they ask is, what's the heat, beat, and treat on Kevlar? You say, okay, well, you take petroleum, put it in sulfuric acid, heat it up to 1400 degrees Fahrenheit, draw it out under enormous pressures, heat, beat, treat. You look at a spider. Spider takes flies and crickets in a web, mixes it up in water, squeezes it out at very low pressures, and out comes a material 5 times as strong, ounce for ounce, as steel. So what's happening now is that people who are studying life's materials are beginning to get the recipes. We're not farming the abalone for its nacre. We're not farming the spider. We're actually borrowing the recipe and making it ourselves.
I think that it should be the way we teach sustainability is through the lens of biomimicry, because sustainability is sounds always like static to me. It's like you're staying in the same place, but you're trying to keep it like that, whereas biomimicry is about moving, adapting and evolving and moving with what needs to change. So it's constant change, which is really what life is.
We think about recycling, that you take a bottle and you recycle it, you break it right down into its molecules, and then you make it into something else. That rarely happens in the natural world. What actually happens, a tree falls in the forest. The log is not broken down into its raw materials. The fungus begins to eat it. The materials in the log become part of the fungus. An organism may come and eat that fungus. The materials in the fungus become part of that rodent. An owl comes in and eats the rodent. The materials in that rodent become part of the owl. So really in the natural world, it's an upcycling of materials. Biomimicry says, implicitly, there's not such a large separation between us and the rest of nature. What organisms are trying to do on this planet is very similar to what we're trying to do.
If we want to sustain life, we have to understand and appreciate that all of human life is entirely dependent on nature. To develop as a human society, we need to take into account that we must live in accordance with life's principles.
We actually have a possibility of beginning to exercise some restraint, and dare I say, maturity, as a species. We've run to the end of our leash in terms of arrogance. And we're ready to, in a prodigal way, in a sense, come home and say, okay, teach me again. What was that again? How do I live here on this planet over the long haul? I think the concept of biomimicry, I think the concept of looking to the natural world for inspiration will become just one of the ways we design. It'll be folded into the toolbox that the people who make our world use. It'll become second nature again.